So this is chapter 8, number 21. Is lattice energy usually endothermic or exothermic? It is endothermic. Why is that? Because you always need to put energy into separate a system or separate a bond. So NaCl, for example, you'd have to put energy in to separate that. And the energy would go into the system, which is your NaCl, to break that bond. Letter B says, write the chemical equation that represents the process of lattice energy for the case of NaCl. So with NaCl, you would take that solid and then you would separate it completely into its gaseous ions, because that's the definition of lattice energy, the energy it takes to separate an ionic substance into its gaseous ions. And so you'd have to put gas down here below each one of those, and then you have to make sure that there are ions, positive and negative, like that. And then letter C, would you expect salts like NaCl, which have single charged ions, to have larger or smaller lattice energies compared to salts like CaO, which are composed of AA charged ions? So remember, lattice energy is equal to some constant K, then Q1 times Q2 divided by D. And Q1 and Q2, these are the charges right here. And if you have positive 1 from sodium and negative 1 from chlorine, you would just have a total of 1 on the top right here. Whereas if you had something like CaO, which is positive 2 and negative 2, now you'd have a total of 4 on the top. And so CaO, since charge is directly proportional to lattice energy, since CaO would have a much larger lattice energy than something like NaCl or singly charged ions. So always look for the charges first, and if they're more positive and more negative, then it's going to have a larger lattice energy than ones that are just +1, -1, or smaller than those.